You're good to start whenever you want to.
Hi, everybody. My name is Dan Merman. I'm an application engineer with Ventaire. I've been here since about 2010. A little bit about Ventaire is we are started in 1984. We are located in Burnsville, Minnesota, just south of Minneapolis. We have a couple different manufacturing facilities. Most of our sheet metal components are made in our headquarters in Burnsville. We manufacture our dust collectors down in New Ulm, Minnesota, and most of our fans come out of South Dakota. Areas that we typically see our equipment is for engine exhaust extraction, welding application, soldering, brazing, laboratories, dust collection, basically anything that can get you sick. Starting with engine exhaust extraction, basically OSHA requires, in addition to general ventilation, they require source capture exhaust in any garages that you're running or working on vehicles. Engine extraction systems are categorized in two different types. There's overhead and underfloor. Overhead, I'd say the most common would be hose reels. We offer both a motorized hose reel and spring powered. I always recommend hose reels when possible, but if those aren't feasible, then we do offer just simple hose drops, telescoping hose drops, boom mounted hoses if some horizontal extension is required to reach some various areas. The two different style underfloor systems that we offer are self-storing. That's where the actual hose stores in the ground itself, and also non-disappearing. Basically, you just plug a hose into the floor fixture. That's typical for larger hoses that can't store underground. We'll cover that later. Factors to consider when designing engine extraction systems. You obviously want to figure out the facility type. Is it auto dealership, public works, garage, school, military applications? Type of vehicles and vehicle engine sizes. Biggest factors when designing is connecting with the owners, finding out their intentions, the expectations of the systems, how they're going to be using it, how many hoses do they require, how do they want to store the hoses when they're not in use, and configuration of fans, and how they're going to be using the system. Is it going to be intermittent use, continuous, long periods of time? Moving on to our hose reels. These are nice just because they pull the hose up completely out of the way. We offer two styles, spring and motorized. Ventaire actually has a US patent on our motorized hose reels. We're the only manufacturer to have a direct drive tubular motor. It's actually concealed inside the drum here. As far as motorized hose reels, we don't really have any limitations as far as sizing, whereas spring we do, just because springs are only so strong to lift the hose out of the way. Standard diameters for spring reels are 4 to 8 inch. As far as motorized, sky's the limit. We have hose reels out there that hold 75 feet of 18-inch diameter hose. These can either be ducted to a central exhaust fan, or we can also provide a direct drive blower on some of these smaller hose reels, which I'll cover later. Here's a couple pictures of some hose reel installation. The one on the left there, that's actually at Little Rock Air Force Base. Those hose reels that you're seeing up in the ceiling are storing 50 feet of 14-inch diameter hose. And what those are actually doing, each plane requires 2 hose reels, and they're used when they're working on the fuel cells of the aircraft. One's pushing and one's pulling to purge the fuel cell. The other couple pictures there, we got some spring reels up at Fort Wainwright, and then also some motorized reels with 8-inch by 50 feet at Fort Drum. And you can see these both are the hose reels are both mounted along the wall. In the top picture there shows a crane, and that's pretty common in military. You have to mount the hose reels underneath the crane path. A couple other pictures of some installations. One on the left there is another aircraft refueling facility for the military at Davis-Monthan Air Force Base. Those are 12-inch by 75-foot hoses. And the picture on the upper right, that's what it looks like when we mount a direct drive exhaust fan to the hose reel. These are nice and compact installations because you are basically the only duct work required is from the fan outlet to wherever you're penetrating the building. The bottom right picture, that's a spring-mounted hose reel mounted to a swivel boom. As I mentioned earlier, booms are nice when you need to extend away from the wall. When hose reels can't be used, whether it's just the facility doesn't allow it or the budget doesn't allow it, we have simple hose drops, rope and pulley kits, cable reel balancers, telescoping, all that good stuff. Moving on to underfloor systems, we have two styles, the self-storing, which I actually put together a picture right here at the bottom. It shows basically everything that we supply for the self-storing. And actually the finished floor would be up here to about the frame. Everything else here is underneath the ground. And then this is the duct saddle that sits over the duct. And then inside the actual ductwork is where the hose stores. This style is limited. I wouldn't recommend going much larger than 4 or 5 inch diameter, about 10 to 11 feet of hose. You just have to make sure the hose stores properly when it's not being used. The plug-in style, that's typical for larger applications where the hose is too large to store underground, so like a 6-inch or 8-inch hose. Here's a couple more underfloor installation pictures. You can see the hose coming out of the ground, and when they're done, basically they'll just shove the hose back in the ground and close the door. These are nice, clean installations. You don't have any overhead duct work except for where you're coming out of the ground. These are typical for newer construction applications because there's not very many facilities where you're going to want to jack up the floor to install some duct work and all this stuff. We offer several different flexible hoses. Basically anything low temperature, which is 250 degrees, all the way up to 2100 degrees. Each application requires different hoses. Diesel, I would recommend starting out at about 600 degrees, which is kind of where we start our standard high temperature. Automobiles would be more towards the lower, what we call lower medium temperature rating, starting at about 350 degrees. There's quite a difference between manufacturers in this industry. And I guess knowing the difference between some of the manufacturers is key when approving and specifying different jobs. Not all hose reels are the same. Pay attention to the thickness of the materials. Ventaire, all components basically are metal in these hose reels. We have several competitors who integrate plastic into the construction. That's one thing to pay attention to when either specifying or approving other manufacturers. The same goes with hoses. Hose temperature rating, it's kind of a game that we see within the industry. Some manufacturers like to fluff their numbers up a little bit. And there's ways to determine what the actual temperature rating is. Every hose has 2 temperature ratings. There's a continuous temperature rating and an intermittent temperature rating. So the continuous temperature rating is basically the hose in an oven without any air movement, and whatever that the breakdown point is, that's typically where you get your continuous temperature rating. Now the intermittent temperature rating is with a fan assisted system. And another way to determine the actual hose temperature ratings is the material. The material doesn't lie. And for instance, like silicone typically starts to break down at about 600 degrees. So that's like a standard high temp hose. When you get a little higher than that, you get up into the thousands of degree ratings. We integrate stainless steel mesh within the construction of the hose. Some information that you guys, when specifying vehicle exhaust extraction equipment, biggest thing is to really connect with the owner and user to obtain this information. What you really want to find out is the engine type, gasoline, diesel, compressed natural gas, the engine displacement. We want that in liters. We don't really need the horsepower. For instance, 500 horsepower. A 13-liter engine can put out anywhere from 500 horsepower to 750 horsepower. So displacement is key. The engine RPM that they're going to be running at while attached to the exhaust system. Aspiration, the turbocharged, supercharged, naturally aspirated, volumetric efficiency, as well as exhaust temperature. And again, it's best to obtain this information from the owner and user so you're accurate from the beginning of the design. It's kind of a quick design guide. Automobiles, light trucks, routine maintenance applications, pulling about 300 CFM through a 4-inch hose. Get into the larger pickups, 1 tons, the 450s, Chevy 3500s, 450 CFM through a 5-inch. Larger trucks, semis, dump trucks, 600 CFM through a 6-inch hose is typical. When you start getting into the heavy duty trucks, farm equipment, generators, minimum 1,000 CFM through an 8-inch. Anything larger than that, I recommend reaching out to Ventaire. We actually do have an exhaust output calculator that we can input all this information on and come up with the approximate output of the engine. In our systems, one of the issues we do see oftentimes is the static pressure is kind of an oversight, and oftentimes you just kind of throw random numbers in there. I wouldn't recommend anything less than 3 inches. With our system, static pressure is never consistent because the hoses are always reaching various locations, exhaust pipes. Sometimes you have a spaghetti of the hose just to reach some exhaust pipes. So static pressure is never constant with our systems. Moving on to welding and fume extraction. Typically, you'll see our equipment for welding extraction in fab shops, manufacturing facilities, career training facilities, schools, garages. A few different ways to capture the fume exhaust. I always recommend fume arms when possible. They're probably the most versatile option. We also offer some fixed hoods or some hose drops with basically an inlet hood. Right here, you'll see with a magnetic base. I think each option has their place, but I always like to recommend fume arms when possible. Factors to consider when designing for welding exhaust. What kind of welding? How do they want to capture the fumes, whether it's the hood, fume arm, flexible hose drop. You got to figure out how many stations you have. And then the dimensions of the welding stations, that's key. Determining the sizes of either fume arms, hoods, length of hoses, etc. And how we can mount either the arm or the hood. Once everything's captured, once the fumes are into ductwork, make your way through the fan, you want to figure out what to do with them. You basically have 2 options. Exhaust it outside, or you can filter it and recirculate it back into the space. I typically recommend filtering and returning it back to space in larger systems so you don't have to worry about makeup air. So this is our self-supporting fume arm. All supports are outside the airstream, making it probably one of the most efficient fume arms in the industry. Available multiple diameters up to 8-inch, length 7 feet, 10 feet, 14 feet. Be wall mounted, column mounted, ceiling mounted. Several options such as light kit, fan switch, all that good stuff. It comes standard with the damper as well. Last slide I mentioned that SIFA is all the supports are outside the airstream. So that diagram on the left shows just kind of simulation of the air through the fume arm with all the supports outside the airstream. The right side shows basically what it looks like for internally supported fume arms. Increased resistance through the fume arm on internally supported, turbulence, maintenance, all those dirty fumes and particulate that are making their way through an internally supported arm, they do get caked up on those internal supports. So they'll have to be taken apart, cleaned, just adding quite a bit of maintenance, plus resistance to the system. At 14 feet isn't what getting the job done. We can mount these SIFA arms to an extension boom, and that's what these pictures show. Standard size for the booms, 5 feet, 10 feet, 15 feet, 20 feet. You don't want to get too long just because they can get cumbersome to use, and it can get to the point where they just don't use them. There's a few pictures of SIFA fume arms installed. These all show essentially ducted options to a utility vent set. The ones on the left, those are 6-inch, 10-foot arms. And the upper right picture, those are actually 4-inch arms for some spot welding applications. Design parameters for welding and grinding. Want to be a minimum of 3,000 feet per minute through the fume arm. That is key. Any less than that, and basically the arm has to be a lot closer to the welding process, which can essentially interrupt the arc. You may even start sucking some gases through the system as well. Heavy duty production, continuous type welding and grinding, I recommend a minimum of 1,100 CFM through an 8-inch arm, up to about 1,400 CFM. Standard welding, about 600 to 700 CFM through a 6-inch arm. Light welding, intermittent welding, 450 to 500 to a 5-inch arm. Light spot welding, about 250 to 300 CFM through a 4-inch arm. I mentioned 3,000 feet per minute through the fume arm. Once you get up into the ductwork, decrease that down to 2,000 feet per minute. As far as static pressure, again, these fume arms are always reaching various locations throughout the booths or whatever you're welding on. So the static pressure is never constant as well. So a good starting point is about 3 inches of static, and that's assuming about 3,000 feet per minute through the arm. You're gonna have to add your duct loss to that. Next up is our slotted fume hoods. These are nice for smaller, dedicated areas like welding booths and schools. I often recommend these for schools because they're pretty much tamper-proof. Kids can't really mess with them, and there's virtually no maintenance. We have 3 standard sizes. FEH3 is designed for a 3-foot wide booth, and we have a 4-inch or a 4-foot and a 5-foot wide. We can customize dimensions as well to meet the specific requirements. Standard construction is galvanized, but we can offer them stainless and offer a few other accessories for our slotted hoods, like side baffles to increase capture velocity, dampers, welding tables, cleanouts. Recommended design for our standard FEH hoods. The 3-foot wide hood, about 800 CFM each. 4-foot wide, about 1,000 CFM. 5-foot wide would be about 1,200 CFM. Typical slot velocity is about 2,000 feet per minute. I would say the only couple downfalls about these hoods are they're only efficient to about 2 feet, welding out about 2 feet in front of the hood face. They also do require a little bit more air than you would for a fume arm. As I mentioned earlier, typical 6-inch fume arm requires about 600 CFM. So you know, 3-foot wide hood is about 800. So that's one thing to keep in mind. Canopy hoods. I only recommend these as a last resort. There are some advantages, but there are some disadvantages as well. Advantages, they're hand-free. You're not going to have to reposition anything like a hood as you would with a fume arm. There's virtually no maintenance other than maybe cleaning it every once in a while. Disadvantages, they are very inefficient, require a lot of air. I just did a selection for an engineer, and the hood was about 6 feet by 6 feet, and at a 50 feet per minute capture velocity, it needed almost about 6,000 CFM. So that's one thing to keep in mind. You can decrease that by enclosing sides with curtains, but still they require a lot of air. Also, the fumes, as they are traveling up into the hood, they pass the breathing zone, so you're still inhaling those fumes. So those are reasons why I only recommend those the last resort. Laboratory fume extraction. Our miniature arms are common for the lab applications. 3 different diameters, 2, 3, 4-inch lengths between 28 to 105 inches. A few different constructions. Standard is aluminum, polypropylene for extra corrosion resistance. Then Apex, we can put a grounding kit on there for explosive combustible applications. 3 different mounting configurations: ceiling, wall, table, and we offer several different inlet hood options. The one you see in this picture here is our clear dome hood, which are nice in laboratories. The lab technicians or students, they can see through that as they're pouring or mixing, whatever they're doing. A couple installation pictures of miniature lab arms. You can see these ones have the clear dome hoods as well. Picture on the right, basically just a ceiling mounted arm, shows a different style hood. It's called a flat screen hood. Next up is our dust collectors. We offer a couple different styles depending on the application. Our DCC downflow cartridge collector, typical for applications with very small particulate, such as welding, smoke, metal grinding, powders. And when we get into applications where the particulate is much larger, we offer our cyclone collector. That can be paired with an after filter as well, but it's typical for applications like woodworking or any application that produces much larger particulate. Here's our DCC cartridge collector. Standard with MERV 15 filters, we offer a HEPA after filter. Comes with the automatic filter cleaning pulse jet system. Basically, there's a pressure transducer that measures the pressure drop across the filters, and if it reaches a certain range, it'll pulse the fumes, and the particulate will, pulse the filters, and the particulate will fall down into that drum down you see at the bottom there. Several different options: outlet silencers, explosion suppression systems. Here's a couple installation pictures. You can see we have a top mounted option and also ground mounted blower option. There are some limitations as far as top mounted. When the fan gets too large, that's when we mount them on the ground. As you can see, these all have outlet silencers as noise is oftentimes a concern with dust collection. And all three of these, you can see they are recirculating the air back into the space. Now, and all three also have HEPA filters that are installed inside. These are CDC cyclone dust collector. Oftentimes these are paired with an after filter, whether it's a shaker after filter, as you can see here. Essentially, there's a motor inside that shaker. It literally just shakes the filters to shake all the particulate off the filters, and it falls down into the drum. This particular system that you see here, that's the 8,000 CFM unit, and we are returning the air back into the space. What you cannot see here is some explosion suppression equipment required for NFPA compliance, such as there's an abort gate damper on the return duct on the other side of here. And then inside the building, we also have a spark detection extinguish system. A couple more pictures of some installed cyclones. This one on the left has another, that's a shaker. This one is actually basically just enclosed hanging filters, and they're manually cleaned and emptied. Basically, you have to go in there, shake them with a manual shaker bar, and the particulate will fall down to the bottom, and then that's where you empty it out. This is not recommended when you're returning the fumes back, or the air back into the space. Picture on the right, that is probably our most down and dirty option as far as after filters. As you can tell, those after filters are just hanging there, so they definitely need to be inside. As far as cleaning them, you just go up there, hit them with a stick, and empty it out manually at the bottom of the zipper there. So those are a couple different after filter options we have for our cyclone dust collector. Exhaust fans, we have access to most of the large manufacturers in the industry. We don't make any ourselves. Twin City, Cook, Penberry, Chicago blower, and New York blower are most common. Typically, when we're essentially ducting hoses or fume arms to an exhaust fan, we're going to use our UVS utility set. Very versatile, and they accept wide varieties of performances. This is our direct drive pressure blower. These are typical for smaller, maybe single hose applications. When we're mounting an exhaust fan directly to a hose reel, this is the fan we use and recommend. Pretty robust. There's not a lot to them, so as far as maintenance wise, they're pretty bulletproof. The only thing that we typically will have to replace some of these is if a motor burns up. And that is pretty much Ventaire's scope here. I'm sure you guys are going to have plenty of questions for me. So Tracy, if you want to